会非常难得，是由来自美国微软总部的微软研究院 Stewart Tansley 博士，还有相关的研究人员，正式对台湾的学术界介绍 Kinect for Windows SDK， 将会协助您了解如何运用这个 SDK 来建立更为丰富的自然人机界面。今天比较不好意思的就是，因为我们现场有太多丰富的内容想要跟来宾分享，所以呢，今天的会议并没有安排特别的休息时间，这点要请大家多多包涵体谅。那如果期间大家想要休息的话，都可以随时到外面去，我们外面还是备有茶水。在活动的一开始呢，我们很开心的可以邀请到台湾微软开发工具暨平台推广处总经理刘念真刘总经理来为我们致欢迎词，让我们掌声欢迎刘博士上台。
各位来宾好哈，这个 Connect for Windows 啊，那 Academic 呢，我们刚刚跟那个Dr. Tansley 来谈，就是说我们大概是从6月的时候，从 MSR 开始推广哈。那其实，在台湾其实不管在业界哈，还有在学界，其实我们看到其实很多人对这个有兴趣啊，所以我们呢还有跟Heidi 是我们那个亚洲这个研究院哈，我们就一直这个同仁一直在构想说，我们是不是能够找到台湾不管在学术界或甚至有一些业界哈，能够对这个有兴趣的，然后我们把这个 Tansley 找来哈，然后大家共聚一堂来一起做这个研讨哈。所以今天其实我个人是蛮兴奋的，也非常感谢各位哈。我晓得有一些还是从中南部哈来这边，然后不管是在学校里的 lab 或者是在哪边哈。我想今天像刚刚讲的哈，就是说我们 Keep 是一个等于说大家交流会，中间大家有问题的话，随时举手哈。那没有 break 中间大家需要休息的话，我觉得我们大家可以来relax 来做这个事啊。那我在前面稍微一点，因为这个机会非常难得所以我们整天会有 connect， 在前面的话我想跟各位稍微来this one。来稍微就说跳出来是从 Connect 整个 Microsoft 来看哈，因为我想这个现在的这个 IT 的这个 environment technology 是在变化哈。那 Microsoft 过去给人印象是在做这个 software OK， 尤其 Windows Office 然后接下来我们有很多的 server 的这些 technology product， 然后在 web 等等那接下来 OK， 在整个 IT 的环境，接下来 Microsoft 在做什么？那我想其实我们在内部很清楚就是说其实现在在总部的 R&D 大家可能不晓得，就是说大概有绝大多数的 R&D 的 force 其实是在云端，在 device 上。我们当然会去 maintain 我们的原来的 software OK， 但是 cloud 跟 devices 我想2年前 Steve Ballmer 先生来就我们的 CEO 讲了一个 3 screen and cloud。大概 3 screen 的话是一个 device 因为我想现在整个 paradigm 到各式各样的 device cloud， 所以从 Microsoft Vision 来看，以后的computing environment 是这样子 OK。那在这里头，我想不管从学术的开发，从 business， 甚至我们从这个咨询的业者的话，我们会朝向这个方向做一个转变。那 Microsoft 也是在做一些 transformation 在做这方面，所以。我看到这个中间比如说这个中间这边的话，其实我们把非常多以前的 software technology move 到云端去，那我们的 Windows 从 PC 即将要展开到各式各样的 device。所以这里头简单来看两个东西，我觉得其实大家可以印象的，就是 Microsoft 是以 Windows 起家，那这边这句话，其实它目前在做非常多的 R&D， 是 extend 这个 Windows 的 technology。to 这个 Internet scale 的这个 cloud platform，OK， 那Windows Azure platform 当然是我们 Microsoft 里头最重要的一个这个云端的这个平台，在这上头可以开发。其实，在过去我们跟不少的学校清大、交大等等，不管在开课在研究方面的话，有这样子的一个 cloud platform， 这是从 cloud 的这个观点来看那从 device 的来看的话，其实今年。在9月的时候，我自己还有我们很多的同仁也去这个 这个加州这边来 Anaheim 哈，做一个，其实在 Microsoft 来看我们来看是 Windows 9以后最 significant 最重要的一个Windows 产品是这个 Windows 8那这里头重要的一点就是说，在 Windows 以往的话是以 PC为 centric， 在过去20年几乎都是这样，但在 Windows 8这个刹那之间，我们希望这边讲 Unified Ecosystem 能够把 Windows extend 到各式各样的 device 平板电脑各方面，其实我们phone 方面也是一些 Windows technology， 甚至到 Smart TV 等等。那这个的好处是，我们希望说在这整块里头有一个非常uniform 的 device driver， 有一个非常 unified 的管理方法，有 unified 的 security 的机制，有 unified 的 development platform。因为我们看到，其实现在我们非常可敬的很多的对手 ，Apple、Google 等等，在 cloud 在 device 上其实是一个做了非常非常好的东西。那 Microsoft 在做这个 transformation， 希望说能够用 Windows， 能够我们讲 reimagine Windows， 能够做到这一点。但是在这整个 platform 能够是用一个很 consistent way 把它串起来的话，我相信对各方面应用的话会是一个那当然这里头很重要，谈到 device 的话，这个从 user interface 来看的话，对不对？我们从 mouse keyboard， 这是 PC 上头主要的，这个，但是我们会走向非常多 natural user interface， 当然 Connect 这个也是我们一个主要的一个今天的 topic。好，所以其实我这边简单来看，跟各位谈从 cloud 的 device 在台湾的这个 schedule，OK， 台湾的 time frame 来看，其实从10月，大家也许有看到芒果机各方面我们跟这个 HTC 合作，在10月初的时候announce的芒果机，然后12月刚过其实跟 Nokia 方面，所以基本上我们看这个目前的这一季了我们是等于说把这个首先是把这个我们希望在 phone 方面是有一些进展那其实，在农历年过后，大概在2、3月左右的话，其实 Microsoft 原来 Windows Office 从 desktop 上云端就是说 Office 365简单来讲，它会是在 cloud 上头的。当然 Office 大家想到是 Word、Excel、PowerPoint， 但是实际上包括了 email， 包括了很多 collaboration 的 tool、communication、video、audio 的这些，整个 Office 365 means 365天运转。我想 cloud 是这种 availability，OK， 那它是一个云端 version Office。那我刚刚有讲 Windows extend 到 cloud 是 Windows Azure， 所以这个 part 其实我们是跟很多的学校跟很多的已经开始做先导计划，但是真正在台湾真正上市的话，可能是在2、3月农历年接下来其实非常重要的其实对 Microsoft 来讲是非常真是一个关键的 platform 是 Windows 8。那我的部门还有在台湾微软这个在 Windows 8不管在 phone 方面上头如何开发 application 它的这个 programming model 是什么等等的话，我们会在接下来明年开始一整年的话，可能会有非常多的一些讲法。所以我想这是大概在台湾不管在 cloud、在 device 上头、在 phone 上头的一些 schedule 那所以我想这个回到刚刚跟这个Tansley 这个来谈说，那我们今天 connect 跟这个 cloud 跟 device 之间关系是什么我觉得等一下我想 Stewart 会来做一个很重要。其实今天我想 cloud 在 device 端cloud 在 back end，OK，device 在前面的话，它因为走向了从 PC out of 这个 desktop，OK，所以说它可能是在任何的环境中出现我们的汽车里头可能是有一个 intelligent device， 我们在任何一个日常生活之下，所以 keyboard mouse 这样子的 user interface 已经不足以支撑以后我们所谓的 pervasive computing 的一个这个环境，因为用的人可能是 general consumer， 他的场合里头并不是在桌上，所以其实 natural user interface 是一个 key 的一个以后的一个 topic。那Stewart 告诉我说，像 Microsoft 的 Connect 和 Windows 这个 Connect 这些 technology 其实是 Microsoft 在 natural user interface 上头的一个 very beginning 的一个东西。那这些 technology 以后会 extend 到各式各样的 device， 以后会有各式各样的 advanced 的这个 technology。所以今天来看的话，这等于说我们在走向这个自然人机 界面的话，还是一个 very early 的 stage。OK， 好，所以大概我讲到这边，那其实我们今天我们很欢迎哈，就是说其实Stewart 他是刚刚有谈到哈，是在MSR 在总部的微软研究院里头是 Director of Natural User Interface， 所以谈到 Microsoft 的这些愿景哈，他在这个最适当的人哈来跟我们谈。So we'd like to welcome Dr. Tansley to give us an overview.
Thank you very much for that very kind introduction. Well, good morning, Taipei. It's great to see you all. Let me get the right clicker here. We've got too many clickers. Here we go. So I was interested to hear that there's a civil engineering conference going on in this building. My PhD is in artificial intelligence, in knowledge-based systems. It's quite a few years ago now, so this was back in the days when we called them expert systems. But the application of that was in civil engineering, so I'm quite torn to go and see my old friends in civil engineering. So I'm from the Microsoft Research Connections group, which is part of Microsoft Research, and we are a bridging group between the world of academia, professors and students, especially in research, and Microsoft Research internally. A number of us are from that group here today. So what I'm going to be doing for the first part of today, before we get into the real event, which is Krishna Kumar, who will give you a hands-on taste of the Kinect for Windows SDK, if you've not already tried this yourself, or even if you have, he's still going to tell you more about it. I want to give you a little bit of a story around the Kinect for Windows SDK, some of the rationale for why we built this, and really what we see, how you can participate as part of this story. Because this is a story for everybody. The entirety of the computer science field and applications of computer science, Kinect is for all of us. So without further ado, let me move on to my slides. Now, one of the things that will be maybe just a tiny bit confusing today, but I hope I will help to explain this confusion today. So we're in a period of transition today. We are speaking from Microsoft Research today, primarily. And Microsoft Research helped make available the Kinect for Windows SDK, and that's why you see a URL which has research.microsoft.com in it, the research site for Microsoft Research. But we are in transition because this is going to be a product from Microsoft, and we're halfway there right now. In early 2012, next year, just in a few weeks' time, essentially, we will have the full product available for Kinect for Windows. And that's been announced, and this is the site. When you go to connectforwindows.org, the current website, you will see that this website, and you will see that's where to download the SDK, it's where to get all the documentation, it's where to get to the forums, all the sorts of things to do with Kinect for Windows. We've even announced that there will be some new hardware, a new device for Kinect, as well as the software. And that's why we say now Kinect for Windows, rather than Kinect for Windows SDK, because the SDK is just one part of the Kinect for Windows product. So there's both hardware and software. So I will, because we're in this transition, I'll be speaking from a research perspective today. You will see research URLs, but the main thing I want you to understand today is it's Kinect for Windows, and it's Kinect for Windows with hardware and software, and this is the website to go to, connectforwindows.org. So now let's tell a little bit about the background story. Some of you may remember the name Natal. Project Natal was the code name for Kinect. Back in June 2009, we announced the Project Natal, and it was at E3, because this was originally just an entertainment technology. E3 is the big computer gaming conference. And the reasons for Project Natal are kind of interesting, because as part of Xbox's trying to figure out how to expand their market, how to get more sales of Xbox, one of the things that they found in talking to their consumers, not only the people playing games, but also the people that could play games, the potential consumers. Often, perhaps our parents, for example, or younger children. Because the game players for Xbox originally were quite well defined. They were hardcore gamers, a very serious kind of gaming community. And this existing gaming community didn't have any problem with a hand controller. But the potential consumers, the people like our parents, they found that it was off-putting to use this hand controller, the device you see on the left. Nintendo had showed that with the Wii, a novel controller for a game could be a really entertaining experience. And they were very successful for a couple of years in the Wii system. But we wanted to take this further. We wanted to imagine, what if you could completely remove the controller, not have any controller, and make you the controller, your own body, the human body, as the device that controls the computer, controls the game machine in this case. And so that concept, Project Natal, was the central idea of a gentleman called Alex Kidman. He had a team in Xbox, and they did some prototyping work. And I'll explain a little bit about how far they got. But to get to this product, just a year or so later, in November 2010, a year ago, almost a year ago and 1 month, when we launched the product, this was just the start of what we see now as a much richer story, originating in this entertainment experience, originating in the idea of having no hand controller for a game. So, do any of you know where Natal, the name, comes from? If you do, I'm sorry, but here's the answer. It's a city in Brazil, and that's where Alex Kidman comes from. Not only did he originate from there, but his concept, and the concept in Xbox then, was the birth of the next generation of home entertainment. No, not just the game, but to transform entertainment experiences much more broadly. And in fact, as we've seen, Kinect is now going outside of entertainment even. So they really were looking very visionary in the Project Natal concept. So the Kinect technology, though, often you think of as that black bar. I don't have one here, but Krishna will have one for his talk. But you've seen this sort of almost iconic black technology. And it would be a mistake to think that Kinect is just that device and the sensors in that device. I'll hold it up. Anybody not seen a Kinect? Here's a Kinect. Thank you, Krishna. But Kinect, the device, is just an array of sensors. And as you know, all of you here, I think, are computer scientists or technologists of some kind or another. You understand that getting information from sensors is a pretty tricky business. They're very noisy. Getting the interesting information out of that signal is difficult, it's challenging. And there's an awful lot of software that goes into this. And so that software provides the brain of Kinect, and that's mostly what we'll be talking about today, and it's what we've given to you in the SDK. We're giving you the brain of Kinect with the SDK. So the story in summary here is that it didn't just come about from that idea of Alex and his team, though. The notion of solving the problem came about from decades of computer vision research, and also computer audio research too. Because we're very keen for you to understand that the Kinect is not just about the vision system, but also about the audio system. And this is where my job fits in with natural user interface. Because Kinect is a tool for building natural user interfaces. Natural user interfaces are ways to interact with computers that fit in with this concept of ubiquitous computing, or ambient computing, or pervasive computing, where computers become immersed in our lives even more commonly than they are today. Today, we still think of distinct computers sometimes when we interact with computer systems during the course of our day. Maybe we're in a car and we're interacting with a computer or computers that are in a car. But that becomes a little bit more seamless with our lives. But we still hold handheld devices or we use a laptop. But in general, the trend is to make computing much more commonly just seamless within our worlds and with our daily lives. And this is where Kinect is helping us interact with this type of computing because it's part of a natural user interface. It's a more natural way to interact with computers because this pervasive computing becomes immersed in our natural daily lives. The Xbox did some prototyping work of this concept, going back to computer games for the entertainment scenarios. But they ran into challenges, and they got a certain amount of the way, but they couldn't solve the whole problem, and it was still remarkable how far they got, as I'll explain. So in September 2008, they needed to call up Microsoft Research, which is the internal research lab, the computer science research lab that Microsoft Corporation has. And Microsoft Research is like a giant computer science department, so you'd be very familiar with it, those computer science. And we have labs all around the world, and they're doing academic research. They publish in the same conferences that you do, they visit the same conferences they do, publish in the same journals. We're often a good help for the product groups where they've got tough technological problems to solve. We're in general working on future technologies, but sometimes those future technologies we can bring forward into today's reality, especially working and helping our product groups. So we launched the Project Natal concept in June 2009 at E3, as I mentioned, and then in November 4th last year, the retail product was announced for Xbox that was released around the world, including Taiwan. What was amazing was we were very proud of the success that this had in entertainment. It sold 10 million units by March 9th, 2011. And that is a remarkable number for any type of product, because it turns out this hit the Guinness World Record for the fastest selling consumer electronics product of all time. Even amongst all the interesting and amazing technology devices that are in our lives today, this was the fastest selling of them. Very, very remarkable. Let's drill into a little bit more about the technology. So you're all computer scientists of some kind, or you know about computer science. You know that this is a non-trivial problem to solve. You know that some of the problem has been solved, but trying to solve all of this together is non-trivial. So in general, though, in the abstract way, what I'm trying to do from an entertainment experience with Kinect is I'm trying to find where the people are in a video stream. So I'm looking with a camera at a group of people, small group, not as big as this, because the scenario that Xbox were looking at was in a living room, playing a game with a family or a couple or a small group of friends. How can I find the people in that scene? And some of you may know how to solve that using algorithms today. We can do that. You need to separate the people from the background. But you're trying to get to a point where they can be the controller, where they can use gestures, like I'm doing now, like I'm waving, to control the gaming system or the entertainment system. And so you need to find where their limbs are, where the joints of those limbs are, and track them and understand where they are, where they're going. You need to just separate which person is which, because it gets very confusing if you're playing a game with two people and the system doesn't know which person is which, because they'll start interfering with each other's scoring. We can't have that with a game. You need to track the gestures more than just the limb movements. The reason, the extra information there is semantics. You're trying to understand that this is not just a random way, but I'm actually moving my hand in a way that has some semantics, has some meaning, which I can now map to a control. So I want to map those gestures now to a control, to a command for the Xbox, for an entertainment experience. A control in a game, or control in the audio-visual system, whatever it takes in the Xbox. It's also helpful in an entertainment experience in the living room to do facial recognition, to understand who in the family member or which group of friends that are playing this game, and have a memory there. So recognizing faces is useful, and we wanted to build that in. And also, again, it's not just about the vision system. We think from a natural user interface point of view, it's very natural for us to all speak in general, and the recognizing voices and commands is an important part of that natural experience, if you have that ability. Remember, this is a software problem, and I'm on a computer system, and I still need to run the application. In this case, it's Xbox, and it's playing a game, or it's playing some entertainment experience. So think about this. I need to do all of this, solve this problem in software, but I also need to run the application too. And the same applies on Kinect for Windows. When you write your applications, you don't want all of the CPU to be used up in tracking gestures, separating people from the background, understanding voice commands. You need a lot of your CPU to be run in your application. And that was very true in our design problem. So this was almost like magic in getting this to work. We used machine learning, a classification algorithm. Effectively, though, in summary, this is evaluating trillions of the possible body configurations of multiple people across 32 of their body segments, is the way the algorithm segments it. And we have to do that every video frame. And in the US, and I believe here, that's doing that at 30 times a second. 30 times a second we have to do this. I have to do that on less than 10% of the CPU because I want 90% of the CPU available to play the game, to run the artificial intelligence for the game, to run the graphics, to run the audio in playing the game. So I need to do this effectively 10 times the speed of real time. And now I hope that some of you may appreciate that's getting to be quite hard. Because it turns out that back in 2007, when we were prototyping this work in Xbox, and then working with Microsoft Research in 2008, that despite decades of computer vision research and also audio research, done both in Microsoft Research and in industry and across academia around the world, the state of the art in how to track human bodies in 2007, it wasn't possible to do this. It was impossible. You could track human bodies. You could do it for a limited set of agilities, a certain amount of movements, a certain number of body types, but you couldn't do it in real time.